Hey there, Kipsters. Mr. Piazzi here, and we are looking at objectives 3A.1 through 2. That's the product of powers and the power of powers rules. These are the first two rules, or exponent rules, of this unit. There's a third one, the quotient of powers, which you'll look at in the next video. So first I want to kind of refresh our memory about how we came up with these rules, which was the discovery we saw when we multiplied powers. So slide 1 is really talking about the product of powers. That means when we are multiplying powers together. So in both of these examples, you have two powers, such as x to the 7th times x to the 5th. We're multiplying two powers together. And the way that I introduce this is to say, okay, let's try to simplify this expression by figuring out what it means. X to the 7th really means x times x times x 7 times. 1, 2, 3, 4, 5, 6, 7. That was this. Times x to the 5th, which really means x times x 5 times. And if we multiply all of those together, in total there's 12 x's being multiplied, which we represent as x to the 12th power. We could also do this with whole numbers rather than just with variables. 5 to the 3rd really means 5 times 5 times 5 times 5 to the 4th, which really means 5 times 5 times 5 times 5. And if you see the pattern, you know that in total this is really 5 to the 7th. And so the rule here is when you're multiplying powers together that have the same base, both of those were x's, both of the bases here were 5's, all you do is add the exponents to get x to the 12th. Add the exponents to get 5 to the 7th. And we're going to be able to use that for higher level applications in a moment. The other rule that I want to look at is then the power of powers rule. That means we're taking a power and we're raising it to another power, for which the rules are different. And again, I'm going to take us back to what these things actually mean, starting with x to the 7th times, raised to the 3rd power. So that means whatever x to the 7th is, we're going to do that 3 times. So x to the 7th means x times x, 7 times. 1, 2, 3, 4, 5, 6, 7. That's x to the 7th, 1 time. But I need to do it 3 times, so I'm going to do it 2 more times. X to the 7th. 1, 2, 3, 4, 5, 6, 7. That's a second time. Times. One, 2, 3, 4, 5, 6, 7. X to the 7th, a 3rd time. In total, if you were to multiply all these x's together, you see that this is really x to the 21st. X to the 21st. You can also, again, do this with whole numbers. 5 to the 3rd really means 5 times 5 times 5. That's 5 to the 3rd 1 time, but we need to do 5 to the 3rd 4 times. So that means times 5 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 times 5. In total, if you see the pattern, you know that this is really 5 to the 12th. And so the rule here is when you're taking a power and raising it to another power, you multiply the exponents and keep the base, and that's how we got x to the 21st. Same here, when we're taking a power like 5 to the 3rd and raising it to another power, keeping the base the same, you now multiply the exponents to get 5 to the 12th. So those are the two rules, product of powers, power of powers rule. And now we need to make sure we're ready to apply them, because this is really going to be the useful skill for next year when we get to algebra. So looking first at A, if I want to simplify these expressions using the product of powers or the power of powers rule, my first step is going to be to do simplify any whole numbers. And second step will be to simplify any variable expressions. So if I'm looking at a 3x to the negative third times 2x to the fifth, the first thing I'll do is actually just reorder it. This is really 3 times 2 times x to the negative third times x to the fifth. I'm reordering it so that I'm grouping them with the same base, so that I have the x's together. 3 times 2 is, of course, 6. X to the negative third times x to the fifth, I'm going to use the product of powers rule since I'm multiplying powers, and I'll add the exponents, which makes this 6 times x to the, let's see, negative 3 plus 5 equals 2. And my answer is 6x squared. Remember, negative 3 plus 5 equals 2, so that's how I got my exponent. Second example, B, I have 2 squared x to the third power. So I'm raising all that stuff on the inside to the third power, and I'm going to use the power of powers rule. In order to do that, that means I need to take every base, which is 2, and which is x, and raise them to the power of 3. 2 to the second power, I'll raise that to the third power by multiplying. And x to the, well, the power there secretly is 1. And I'll get that new exponent by multiplying 2. 2 to the second power to the third power is going to become 2 to the sixth power, because I'm multiplying the exponents. And x to the first power, to raised to the third power, is going to be x to the third, because 1 times 3 is 3. And that's my answer. Okay, for guided practice, I'd like you to try C and D. Press play when you're ready to check your answer. Okay, you've tried C and D, so now it's time to check. 6x to the third times negative 3x squared. Even though there's parentheses, it really just means you're multiplying those things together. I'll regroup first. 6 times negative 3 times x to the third times x squared. 6 times negative 3 is just multiplying, which is negative 18. And x to the third times x squared, you add the exponents using the product of powers rule, and it should have been negative 18 x to the fifth. The next one, which says 3b to the negative third raised to the negative fourth, is actually a multi-step problem. First, you're going to distribute the 3 to the numbers inside. So we're going to raise 3 to the first and b to the first to the negative third power. And if you do that, 3 to the first raised to the negative third is really 1 times negative 3. That would be 3 to the negative third times b to the negative third. All still raised to the negative fourth power. All still raised to the negative fourth power. I'm trying to clean up a little so you can see that this has 3 to the negative third. Then if you raise both of those negative thirds to the negative fourth power, you need to raise both of them to the negative fourth power. So this is going to be 3, negative 3 times negative 4 is positive 12, times b, negative 3 times negative 4 is positive 12. This would be 3 to the 12th times b to the 12th. And that should have been your answer. Okay, it's time for independent practice. I'd like you to try these 5 problems. After you've completed these, submit your answers. If you get a blue ribbon for this independent practice, you should be ready to retake objective assessment 2A.1-2. Good luck.